Hello students, welcome to the subject called compressible fluid flow. So this is the first session for this particular subject. We'll be discussing the first part or the introductory part of first module in this subject. The subject code is ME409. Please note it down. The subject is compressible fluid flow. Myself, Praveen Kumar, Assistant Professor in SNGCT, Mechanical Department. So students, shall we start? So students, you might have studied a subject called fluid mechanics or fluid dynamics, right? In your previous semesters, maybe in your third or fourth semester, right? So what was the significance of that particular subject? Significance of fluid mechanics or dynamics. It is very important to study the subject called fluid dynamics because why? Because most of the processes occurring in nature, starting from minute movements in Earth to the formation of even the on a vast scale galaxies, formation of galaxies, everywhere, all these things involve fluid dynamics, right? So understanding this dynamics of fluid motion, if you study this particular fluid dynamics, it helps to utilize and control the fluid motion in various natural and scientific systems for the benefit of our society, right? So if you study fluid mechanics, you can utilize or control the fluid motion. So you can see fluid motion everywhere. Fluid motion everywhere. So if you study the mechanics of this motion or dynamics of this motion, you can effectively control the fluid motion, or you can effectively utilize that fluid motion for our benefits, right? So what is compressible? Our subject is compressible fluid flow. Compressible fluid flow, right? Compressible fluid flow. The previous subject, fluid mechanics, was simply fluid mechanics only. This is compressible fluid mechanics, right? So what is the difference here? So what do you mean by compressible fluid? Have you heard of that word, compressible fluids? Yes. So compressible fluid. What is compressible fluid? It is those fluids which undergo change in density. So such fluids are called compressible fluid. Their density or their volume can be changed by what? How can we change the density of a fluid? By due to change in either temperature. If you change temperature of a particular fluid, some fluid will undergo change in its density. Such fluids are called compressible fluid, or due to change in pressure. So either by changing temperature or pressure, if we are able to change the density of that particular fluid, then such fluids are called compressible fluid. Have you got the idea? So what is compressible fluid? Compressible fluid are those fluids which undergo change in its density or volume due to change in temperature or pressure. So such fluids are called compressible fluid. So students, the fluid you have studied in the subject called fluid mechanics. In fluid mechanics, the fluid was incompressible, right? The fluid was incompressible. Isn't so? Yes, because in fluid mechanics, you have used the fluid under study was incompressible or liquids. So most of the liquids are incompressible because the various equipments or devices you study it, like a turbine or pumps, everything was hydraulic, right? So these hydraulic equipment or machines or devices are those devices which run on water, right? So water water is a liquid or incompressible, right? Incompressible. So students, what do you mean by fluid? What is fluid? Have you got any idea? uh, how can we define fluid? So you may tell a definition like your definition will be like anything anything that flows, anything that flows, right? So such all those state of matter, that flowing state of matter is called fluid, right? So fluid can be of two types. One is liquid, other is gas, right? Gas. Actually, the scientific or in an engineering point of view, the very that a particular definition is there for defining a fluid, right? So fluid, when asked to an engineer or mechanical engineer, he should reply with this particular definition for fluid. So what is that definition? Those those matter that cannot resist shear force. Shear force, right? So this is what fluid is meant by. Fluid is those substance that cannot resist shear force. When a shear force is applied, it continuously deforms. Such matter is called fluid. I will make you understand. Suppose this is a solid. If you apply a shear force on top of this body, naturally shear stress will develop. In case of solid, it will resist any deformation. The solid will resist any deformation due to this applied shear force. But in case of liquids, some liquid is present on this plate. If I am applying some shear force parallel to that liquid, what will happen? It cannot resist this shear force F. It will, due to the effect of this shear force, it will start to flow. Right? Have you understood? When a shear force is applied, when some force is applied on that stagnant water, it cannot resist that shear force due to the inefficiency of that state of matter or that substance to counter the effect of that shear force. It will start to flow. That is why this particular state of matter is called fluid. It cannot resist the shear force. It will start flowing. So that's how you have to define fluid. Any substance that is capable of flowing, or any substance which continuously 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 deforms when shearing force is applied. So that is what a fluid is meant by. Now there are two types of fluid. Okay, two types of fluid, maybe liquid or gas. Liquid, gas, right? Now liquid is usually incompressible. Its density won't change that easily, but gas compressible, right? Now in your previous semester, the subject you have studied is nothing but fluid mechanics, but you use the fluid that was used in that case was mostly liquid, so that was incompressible. So actually, even though the name is fluid mechanics, its name should be incompressible incompressible fluid flow. Actually, that particular subject was incompressible. That subject mainly dealt with incompressible fluid flow. But in this particular subject, we are going to learn about compressible fluid flow. Compressible fluid flow. That is mainly gas. Right, gas. That is why it has got another name called gas dynamics. So earlier in your Kannur University and all, this subject, the name of this subject was gas dynamics. Most of the books, textbooks have got a name like gas dynamics. So gas dynamics is same as that of compressible fluid flow. So students, have you got that basic idea of what this subject is meant to? I hope you have understood what is the difference between liquid and gas, or what actually is fluid. What is the difference between liquid and gas, or incompressible fluid and compressible fluid, right? So students, CFF is nothing but compressible fluid flow. So what is the importance of studying this particular subject, CFF or compressible fluid dynamics or gas dynamics? So this subject is to be studied. Why? Because this subject is concerned with the causes and effects arising from the motion of CF or compressible fluids. So mainly this subject is concerned with the cause and effects arising from the motion of gases, because with the development of gas turbines, or so you might have heard about gas turbines, or jet propulsion, aerodynamics. Have you heard of aerodynamics is very important in designing aeroplanes, even in our cars and all, because these cars are moving in uh, while cars are moving, there is motion of air over the body, right? So you have to design cars in such a way that you can reduce the effect of air, like lift and drag. You will study these things in these terms, like drag and lift, in coming sessions. So don't worry about these technical jargons. Okay. So in order to design all these things, you must know, because air and all is a gas. Air is in gaseous state, right? So you have to, when you have to design a particular vehicle, or like a vehicle, or either mm, aeroplanes and all, you have to study the properties of air, how this air, what is the effect of flow of air over these vehicles, what are those effects. In order to understand those effects, you have to study the subject, you have to study the dynamics of that particular fluid, right? So that is the importance of this particular subject. So gas turbines, these turbines are usually used in aeroplanes or jets, rockets and all, jet propulsion. All these things you have to know the dynamics of the gas. So that's the importance of this particular subject, right? In fluid mechanics, you have studied the hydraulics, because in hydraulic pumps, hydraulic turbines, how the property, how this properties, or how you are applying the idea of fluid in analyzing those hydraulic devices, right? Here we will analyze this devices working using this gas, right? So classic fluid dynamics, or our fluid, that fluid dynamics, in the in this subject you have studied in your previous fluid dynamics or classic fluid dynamics, you have only studied fluid motion. But in the case of compressible or cff fluid motion, you have to study fluid motion plus the thermal plus chemical effect also, chemical effects also. So in the that fluid mechanics, you don't have to worry about thermal and chemical, but here, but in cff you have to worry about, you have to take into consideration this particular aspect also, because thermal effects, the change in temperature will bring change in density of that particular fluid, like gas, so that will affect the property of the flow. Even chemical effect will change the enthalpy or energy of that particular fluid. Energy will in turn change the temperature of that particular fluid. So these things are related to each other. So you will understand more about these things when things get proceeded. So for the time being, you just keep it in mind that here we are not only studying the fluid motion of the compressible fluid, but also the effect on the properties of the compressible fluid due to the thermal and chemical effect also. So on the whole, this is a culmination of mechanics, thermodynamics, thermodynamics or air and aerodynamics, okay, and chemical kinetics. So studying a compressible fluid flow means you are studying the mechanics of the fluid, thermodynamics of the fluid, aerodynamics of that fluid, and chemical kinetics also. Kinetics, okay, kinetics, chemical kinetics also. So this subject is a culmination of all these four different branches of science. Okay. So what are the applications of this compressible fluid flow? The study turbines you can study. You will be able to know the details about turbines, gas turbines, turbo compressors, or high speed aerodynamics and jet rockets, missile propulsion, all these things. And you will be able to if you know the theory of compressible fluid flow or compressible fluid dynamics, these things are very essential for obtaining optimal design of these gas turbines, rockets, jets, missile propulsion, turbo compressors, everything. So you need to study this particular subject. So this is the importance of this subject. Hope you have understood the introductory part of this subject, or the importance or the scope of studying this particular subject, right? So the fundamental physical laws, fundamental physical laws that we should know as a prerequisite to study this particular subject, or the flow of compressible fluid, are: first one, conservation law of conservation of mass, law of mass conservation. Second one, conservation of momentum conservation. So students, momentum conservation is nothing but the second law, or there is nothing but same as that of second law of motion, second law of Newton's second law of motion. Okay, that is same as that of law of momentum conservation. Third one, first law of thermodynamics. First law of thermodynamics. Fourth one, second law of TD. So all these things, you have already studied this, and you have to be thorough about all these four different laws. First one, law of conservation of mass. Mass is neither created nor destroyed, it is only transferred from one form to another. Second one is Newton's second law of motion, means the conservation of momentum. Okay, conservation of momentum. The change in momentum is the total force acting on that body. That is what conservation of momentum is meant by. Third one is first law of thermodynamics. First law of thermodynamics is nothing but cyclic integral of work will be equal to cyclic integral of heat, or total energy is always conserved. That is first law of thermodynamics. Fourth one is second law of thermodynamics. It gives the direction of a spontaneous process. You know about the Clausius and Kelvin-Planck statement of second law of thermodynamics. So all these things, all these four different laws are very essential in studying compressible fluid flow. Okay. Now we will move to once more we will define two types of fluids. First one, liquid. What are the properties of liquid? Basically, liquid has a definite volume. Definite volume is there. Okay, definite volume. Incompressible. Incompressible means this volume may slightly vary with pressure and temperature, but in normal case there is no the changes are very negligible. So these liquids are difficult to compress. It cannot be compressed, or its volume cannot be decreased, or the densities cannot be changed. That is why these liquids are called incompressible. They are considered as incompressible for most of the practical purposes. Okay. So this is what liquid is meant by. Second one, gas. Gas is it does not no definite volume, right? Gas always take the shape of that volume, the shape of the container. it always takes the shape of the container. If the amount of gas is much lesser than this volume of container, the gas will expand so that it completely fills the container and take the shape of that particular container, right? Okay, so even liquid also take the shape of the container, but its volume is definite or constant. But here the gas will change its volume such that it fills the container completely. So that's the particular property of gas, and it is compressible. Compressible means it can be easily compressed, or its volume can be easily changed by applying pressure. Changing volume is the density of the changing volume means its density is also subjected to change, right? So that is the definition of liquid and volume. You must be very much thorough about these basic definitions. Then only you will understand the things that is followed in this chapters. Okay. So students, you have to take care of a particular aspect of this things that I have told you just right now. So there is a difference between compressible fluid and compressible fluid flow. Okay, these two things are slightly different. I will try to make you understand with an example. So you have got some ducts where some air conditioned air is flowing. Air is flowing. Okay. So this air conditioned air is flowing through a duct at a constant velocity and constant temperature. This air conditioned air is flowing through a duct to a space where air conditioning is to be done, or the space where cooling is to be done. So while this air is flowing through the duct, the velocity is constant and temperature is constant. But students, you know, the fluid under consideration is air. Air is nothing but gaseous in nature. So, so naturally, this is a compressible fluid. But since the velocity and temperature is constant, the density doesn't no change. No change in density. Density of that particular compressible fluid does not change when it travels along that particular duct. So even though the fluid is compressible, the flow under consideration here is incompressible. So this flow is an incompressible fluid flow. Since the velocity and temperature remains constant, the density of fluid remains constant. So the flow is incompressible even though the fluid is compressible. Have you got the idea? Have you got the idea? So the flow under consideration is an incompressible. Here it is incompressible flow. Even though the fluid is compressible, the flow here is incompressible. Why? Because velocity is constant, temperature is constant. All these things are maintained to be constant for this particular requirement only. Okay. If the velocity and temperature changes, sometimes the density of that particular changes, then this flow will get changed or converted into a compressible flow. But as long as the velocity and temperature remains constant, this will be an incompressible fluid flow. So students, you have to understand the fact that The word the word compressibility and incompressibility in this subject does not is not based on the fluid, but based on fluid flow. Based on flow, whether the flow is compressible or whether the flow is incompressible. That is what we are studying in this particular subject. Okay. So another example. Uh, Another example, you have some incompressible fluid like a liquid. You have some incompressible fluid, but subjected to extreme extreme pressure change. So due to that extreme pressure change, the flow this incompressible fluid is made to flow in a particular tube or pipe subjected to some extreme pressure change. Due to that extreme pressure change, there may be change in density. Chances of change in density is there. So even though the fluid is incompressible, due to that pressure change, there may be chance of change in density. So the flow has become compressible fluid flow, even though the fluid was incompressible. So that's the difference. So here you have to make sure that the compressibility is based on flow of fluid, not the fluid, not based on fluid, it is based on flow of fluid. So that is what we are studying here. Compressibility can be defined on basis of fluid also, but here we are studying based on fluid flow. So that is a very basic idea. So usually the limiting condition for arriving at a demarcation between compressible flow and incompressible flow if Mach number, you will study what Mach number is. If Mach number is less than 0.3, uh, the flow is incompressible. And if Mach number is greater than 0.3, flow is compressible. So what is Mach number? I will give you the definition. Mach number you will study in detail in coming sessions, and for the time being, you just try to understand that Mach number is nothing but a ratio of flow velocity to velocity of sound in that medium of flow. Suppose you have a gas flowing with a particular velocity, so that's the flow velocity. Ratio of that flow velocity to the velocity of sound or some infinitesimal pressure pulse in that particular gas. So that ratio is called Mach number. Okay, we will study in detail in the coming sessions, so don't worry about it. For the time being, if Mach number is less than 0.3, it means incompressible fluid flow, not fluid, incompressible fluid flow. If Mach number is less than 0.3, and if Mach number is greater than 0.3, it means compressible fluid flow. Okay. So students, there are two types of approach to study this particular subject or like you have studied these things. You have studied these two different approaches in your previous mechanics subject or fluid mechanics subject itself. But still, I'm just telling this once more. So there are two types of approach: molecular approach and continuum approach. Molecular approach is nothing but microscopic level. Microscopic level. Continuum is nothing but macroscopic. Macro. Right. So in microscopic approach, the process involving fluid are described from the molecular standpoint. Okay. So we will take care of, we will consider in molecular level. So the fluid is considered as collection of some discrete molecules or atoms which are in random motion and undergo collisions with each other. Okay, the conservation of mass, momentum, energy, all these are applied on this particular molecules. And for getting the total quantitative description of the flow, we will be averaging all these microscopic solutions for all the particular microscopic molecule. We will be having a particular value for particular property. For getting the total value of property, we will be taking the average of these microscopic solutions. So that is what molecular approach. In case of continuum, continuum is some macroscopic level approach, right? So here the detailed molecular structure of the fluid is replaced by infinitely divisible substance called continuum. The concept of continuum make it possible to deal with fluid on a macroscopic scale, right? So it is assumed that every differential element of a body contains a large number of molecules, right? Every body is made up of large number of molecules, and the average statistical properties of the molecules contained in an elementary volume represents the macroscopic properties of the fluid at a point in region of that in that elementary volume, right? So since each fluid properties in since each fluid property in a continuum has unique value at each point in space, all fluid properties are continuous functions of motions and time. So that is the idea of continuum approach. Means we are taking the system as a whole. So we are not going to microscopic level. We are taking the system as a whole. So the mean free path of the molecules are the mean free path of the molecules under consideration. Molecules of the system under consideration is lesser than, right? If the characteristic dimension of the system under consideration is very small compared with the mean free path, okay, that's the right way to put it. If the characteristic, I will write it. If the characteristic dimension of the system is small compared to mean free path, then you cannot continue. And then continuum is invalid. So what is the definition? If the characteristic dimension of the system, suppose you have a system, so this is a particular dimension L. So you have got many molecules here. So what is mean free path? Mean free path is the average distance traveled by average distance traveled by the molecules after successful collisions. So these molecules will collide with each other, and after that collision it will move a particular distance. So the average of all those distance is called mean free path. If mean free path is very much larger than the length or the dimension of this particular system, then we can take the continuum approach. But if this mean free path if the mean free path is larger than the L, we cannot, the continuum is invalid. If the length, if the dimension, if L is greater than mean free path, if L is greater than mean free path, we can take continuum approach or microscopic. If L is less than mean free path, continuum is invalid, very less than. Here we have to go for microscopic level of approach. Okay. So students, another important aspect you have to study is what is system. So what is system or system approach? System approach. If we are analyzing a problem by concentrating the study on a quantity of matter, fixed quantity of matter, you are studying by concentrating on a fixed quantity of matter, then that type of approach is called system approach or closed system approach. Okay, or if you put it in a simple form, system approach. Okay, this fixed quantity may have a particular boundary. So anything external to this boundary is surrounding. This is system. So this is boundary. This boundary may be fixed or moving. Even if it is moving, the amount of matter enclosed in that particular moving surface will remain fixed or constant. That is system approach. So every equations that we will be applying will be subjected to that fixed quantity of matter only. Another approach is called control volume approach or open system approach. You might have already studied in your previous subjects, most probably in your fluid mechanics subject. What is this kind of approach? So here you will identify a particular fixed volume and for study. The study will be your study will be concentrated on a fixed volume. That volume is called control volume. The boundary of that particular volume will be control surface. So there may be change in amount of mass. The mass and the mass of the matter, or the matter may not be fixed in that particular volume, but the volume remains fixed. Okay, so that is why we are calling it as open system, because there may be continuous flow of matter. Why it is called open system? Continuous flow of matter from and to the control volume. That is why this particular system is also known as open system. So suppose this is our control volume. Mass not constant. m dot in is there, m dot out is there. So this is control volume. This boundary is known as control surface. So mass does not remain constant. There is influx of mass, there is efflux or outflux of mass, there is energy out, there is energy in. So this is the control volume approach. But in case of fixed system approach, mass equal to constant. Volume may change or the boundary may change. Boundary, if the boundary is moving, it means the volume changes, right? So this is system approach. System approach. Energy in will be there, energy out will be there, but mass input will be 0, mass out will also be 0. So that is the difference between system approach and control volume approach. Okay, for the time being, these are the introductory part of this particular subject. So for the time being, I am stopping this session here. In the coming session, we will move on to the various laws like conservation of mass, momentum, energy, second law of thermodynamics and all. Then you will get a more clear idea of what we are dealing in this subject. So the basic concepts have been discussed in this particular session. If you have got any doubts, you can contact me. Thank you.